12.1 gets split, 12.1a, 12.1b. So we're just doing A today. And it is dealing with tangent lines. And I think people see that and they go, oh, we have to do trig again. You don't. It's not SOHCAHTOA tangent. It's a tangent line. It's a line that is tangent to a circle, which is not going to use that tan button on your calculator at all. So if you didn't love SOHCAHTOA, don't stress. It's not that tangent. A tangent line, okay, is the line that you're seeing here. Line AB, we would say, is tangent to this circle. And what that means is if it's tangent to a circle, it's going to hit that circle in exactly 1 point. Okay, in other words, it's just going to brush that circle so exactly 1 point hits, not 2, right? If I went here, I'm hitting my circle in 2 places. That is not tangent. Tangent can only hit in exactly 1 point. Okay, the point of tangency is that point where it hits the circle. So point B here is where I'm hitting that circle. That's my point of tangency. So when you hear tangent, think just that 1 point that is going to hit my circle. Okay, so there is a theorem. It says if a line is tangent to the circle, then the line is perpendicular. What does it mean to be perpendicular? Not together. Like the, no, not parallel. Perpendicular, right? The T, it's going to form that 90-degree angle. So when you see perpendicular, you should be thinking 90 degrees, okay? Perpendicular to the radius at the point of tangency. Okay, so let's talk through that. Here's your radius, right? Here's your line. So my point of tangency is P. That means I have a right angle from that line to my radius, okay? That is perpendicular every single time. So if you have a tangent line and it connects to a radius, that's always going to form a 90-degree angle. All right, so look at this first example. It says ML and MN are both tangent, meaning here's a point of tangency, point L, and here's a point of tangency, point N. What is the value of X? Now, this looks a little tricky. It's really not that tricky. If a line that is tangent is always perpendicular, what is the measure of angle L? 90. Okay, what's the measure of angle N? 90. Okay, now look at this. Here's what people tend to forget. I have what shape? A kite. It is a kite. It's a quadrilateral, right? How many degrees in a quadrilateral? 360. So that means that 90 and 117 and 90 and that X should add up to 360, right? It is a quadrilateral, has to add up to 360 if it's a quadrilateral. So we're just going to do some basic math to simplify that. When you take all this away, does anyone know what that equals? I don't have it written down. 180, 297, yep. Okay, so if you take away that 297, you get X is equal to 63 degrees. Does that make sense? Yeah, Belle.
Since the L and N are both like right angles, could you just subtract 180 and then just do 180 minus 180?
Yep. Yeah. Okay. Look at this next one. It says ED is tangent. Okay. What's the value of X? What do you do different on this one?
Equals 180.
It equals 180. Now you have a triangle. Okay, so pay attention to how many sides your figure has. You have a triangle. This one has to be 90. So 90 and 38 and X will add up to 180. So we're going to take away that 128 on both sides. And X is going to be 52 degrees. Okay, so when you see a tangent line, your first thought should be what? 90 degrees. Okay, when you see a line that is tangent, think, okay, I know it's perpendicular to the radius. 90 degrees. Okay? Questions on that? Okay, so that was dealing with angle measures, right? Now this next one doesn't deal with angle measures anymore. Same idea, but you do it differently because we're now dealing with side lengths instead. So here's the deal. You have this CNN tower in Toronto, Canada, that has an observation deck 447 meters above ground level. About how far is it from the observation deck to the horizon? So this right here, they're saying how far is it from here, from T, to the horizon? How far is this? So call it X, okay? TE. How far is X? They already converted for you, which was nice of them, 0.45 kilometers. So you don't need to worry about this 447. We're not using it. Can anyone figure out what? Who said that? Whitney? Good job. Pythagorean theorem. Why can we do the Pythagorean theorem right here? It's a right triangle, right? If this is perpendicular because it's tangent, you're looking at this triangle. Notice a radius is a radius no matter where you put it. So it's 6,400 here, but it's also 6,400 here. So you're essentially looking at this right triangle. One of them is 6,400, one of the legs. The other leg is what we're solving for. And then your last leg is 6,400.45, right? We're just adding this to this. Does that make sense? So you have your right triangle. You just need to do the Pythagorean theorem. 6,400 squared plus x squared should equal 6,400.45 squared. Some of you are still doing this wrong, and maybe it's my fault because I shorten it for you. If that messes you up, don't shorten it, okay? Plug it in as you see it. 6,400 squared is a very large number. This is why I don't like writing it all out, but I will for anyone that needs it, okay? I wouldn't do it this way, but I'm going to show you for those of you that are making the mistakes on this. You may write the whole thing out like this. Okay, what I would do is not this. I would just plug in 6,400.45 squared minus 6,400 squared, okay? I would just do this, but here's the deal. So many people are subtracting and then squaring. Don't. Just plug it into your calculator how you see it. 6,400.45 squared minus 6,400 squared. If you subtract first and then square, you will get the wrong answer every time. You want to square and then subtract, okay? So if you're gonna do it that way, you're subtracting this whole thing right here. Again, I'm not gonna write it down. You should get, plug this in, see if this is what you're getting, 5,760.2025. Did you get that for your x squared? So what's your last step from here? Take the square root. So you get x is approximately second square root of that answer. You get 75.89599. That keeps going. So about how far is it from the observation deck? We would say it is approximately, we'll say 75.9 kilometers. Okay, it's really just the Pythagorean theorem. Do the Pythagorean theorem. Any questions on that? Okay, last one is the fun one. And then we're done and you'll have some time to work. Look at this setup. The question is, what is the radius? So in other words, they're asking, what is x? What's the value of x? How do you set this one up? Dance party? Is that how you set it up? No?
Oh, when using the
Pythagorean theorem
12 squared plus x squared plus 8 squared.
equals what?
8, is it 12 squared plus x squared equals 8 squared plus x? Because you're adding 8 plus x squared.
That's the one. So
8 squared plus
x squared plus 12 squared, right? This squared plus this squared. This is your a and your b, or b and a. Doesn't matter. 12 squared plus x squared, that's fine too. But it's got to equal the hypotenuse which is x plus 8 squared. Okay, now here's where all the mistakes get made. What is x plus 8 squared?
X squared plus 8 squared.
Nope, but that's what everybody wants to do.
Oh, it could be 8 squared plus x.
Product and then squared.
It's the product that makes it the squared, right? What do we do with that?
Oh, squared? Or,
It's basically this, right? X plus 8 times itself.
Oh!
What do you do with that?
Oh, that's x.
Foil! You're gonna foil! Yay!
I actually hated
Okay.
that chapter. I really algebra, like.
Okay, well, you won't. Foiling's easy now. We've got this. Okay, so here's the deal. It's just FOIL. Don't let FOIL freak you out. You've got FOIL. Do you want me to teach you binomial Benny?
I remember.
Oh, we know this!
Did you do binomial Benny? Did I teach you binomial Benny? No? Oh, Brandon did binomial Benny?
Use extra credit for the best one on the test.
This is.
Oh, really? Oh, I like that. Okay, here's binomial Benny.
This never works.
Here's his eyebrow, x squared, right? Here's his other eyebrow. I shouldn't have started writing. His nose. And his mouth. Do you see him?
Oh, Lord.
It's binomial Benny. It's first, outside, inside, last, right? We know how to foil, guys. We know how to foil.
Does it matter the order?
No, you can go in any order.
Yeah, I thought you could go.
Yeah, it doesn't have to go first, outside, inside, last, but that's what FOIL stands for. So that's how I'm going to do it, just to not confuse you. But it's going to be this. X squared plus 144, right? 12 squared equals, now I'm going to go first. X times x is x squared. Then I'm going to go outside his mouth plus 8x. Then I'm going to go inside his nose. That sounds weird. Then I'm going to go last. 8 times 8, 64. FOIL. Some people see it as a 4-letter offensive F word. It's just FOIL. It's okay. What?
It was like really bad and we had to do like multiple, like, it was just more than that.
Well, this is always FOIL. You've matured so much. Now it's like, oh, this is easy. I've got
But
this.
it was harder than there's something else.
I mean, we ended up doing more to it eventually, but to initially FOIL, this is it. Okay, so if we simplify x squared plus 16x plus 64, we're trying to solve for the value of x. What do you do next?
Combine,
Combine what?
8 x's.
the 8x's.
Oh, I did that already.
Subtract-
Sorry.
subtract x
16x. Yeah, so now take away x squared. If I take away an x squared here, I have to do it on the other side, and look how nice that is. It's just gone. They go away. 0. So 144 equals 16x plus 64.
Minus 164.
Take away your 64. I'm running out of room. I'm going to move over here. So 144 minus 64, that's 80, equals 16x. Divide by 16. What does that come out to? 5, right? So the radius would be 5. Now here's the deal, guys. You can check this. Because if I put a 5 in here, and I put a 5 in here, that means I have a triangle with side lengths of 5, 12, and 13. Is that a Pythagorean triple?
Yeah.
Yes, it is. You guys are so smart. That's it. FOIL. First, outer, inner, last. Good? Okay.